Okay, so in class, we showed that for an object who is changing mass, the change of momentum, dp dt is m dv dt plus dm dt v minus u, and that was the net external force. And that also is sometimes useful to rearrange this as m dv dt equals the net external force plus dm dt u minus v, which is actually the relative velocity. And I've rearranged here to change the order when I moved it to the other side. So that means that this is F net plus dm dt v relative, okay? And we said that a very common situation where we might want to apply this is for a rocket that's burning some fuel at a rate r. So that means that its mass is m naught minus r t, where m naught is the initial mass, and then the rate of change of mass, dm dt, is negative r, okay? And in this situation where we've got a rocket, we would assume that the net force is that of gravity, so that's negative mg. And then we can use this equation to find v as a function of time, okay? So we're going to substitute things in up above. We would find that m dv dt is negative mg minus r times the relative velocity. Okay. And we said that also this the ux is the rate of expelled material. So that is our VREL, right? Okay, so we're going to assume, let's draw a picture here actually. So we've got our rocket that is moving upward, okay? And we want to know if it starts with v naught is 0, what is v as a function of time? We're assuming that it's going straight up here, so v is just vy j hat, and we can make this equation into a scalar equation instead of a vector equation. And our u expelled vector is, oh, I didn't mean to write it that way, is negative u expelled j hat. So it's also just going straight down. Okay, so I'm going to divide this equation through by m, and I get that dvy dt is negative g minus r over m times negative u x. Okay, so dvy dt is negative g plus r ux over m naught minus r t. And then I want to integrate this to find velocity as a function of time. I'm going to define, say, I'm going to go from 0 to t naught, 0, no, sorry, not 0 to t naught, 0 to t. We're going to assume my initial time is 0. And then I'm going to call this t prime just so I'm not integrating with respect to that same variable. So Vy of t minus Vy of 0 is negative g of t prime. And then this second integral is a little harder, so let's do this one separately. So r, I'll pull out the rux actually. Rux 1 over m naught minus rt dt. Okay, so what's the integral of 1 minus m naught minus rt dt? That integral is going to be the natural log of 1 over m naught minus r. Oh, sorry, this should not be 1 over. That is going to be the natural log of m naught minus rt times negative 1 over r evaluated from 0 to t prime. Okay, and so that is negative 1 over r log of m naught minus r t prime minus natural log of m naught. Okay, and then we can combine these to get negative 1 over r log m naught minus r t prime over m naught. There, what's our rule for subtracting logarithms, and then we can turn this fraction upside down if we pull the negative inside. So this is 1 over r log m naught over m naught minus r t prime. Okay, so now this here is this second term from up here, right? So now putting this all together, we've got that Vy, and we're going to assume Vy of 0 is 0, is negative gt plus r ux over r log m naught minus rt. I've now dropped all my primes and made them back into just t's. So we've got negative gt plus u expelled log m naught over m naught minus r t, as we said in class. Okie doke.